So first of all, R4, so R4 needs a 4 linearly independent vector in order to be spanned. So we can, just by looking at it, by observation, we can say the answer is no, it's not going to span R4, but we can just show, I can show you the work. So you need a 4 vectors, 4 linearly independent vectors in order to span R4, but we can show it here. So 1, 0, negative. So put them, put those as a column of the matrix. Then we'll reduce it. So this is our pivot position. So we're going to make the third one 0. So R1 plus R3, and we put it back in R3. 1, 0, 1, 0, negative 1, 0. And this is just going to be 0, 0, 1. And this is still the same right here, right? And this is our next position, but we can turn this into positive, right? If you just multiply it by negative 1, you can change that to positive 1. So this will be our next pivot position that we have to make this entry 0 next, because this is already 0, this is already 0. Okay, so negative R2 plus R4, and we put it back in R4, which this is 1, 0, 1, 0, 1, 0, 0, 0, 1, and this will turn into 0 completely. Now, this has a pivot position, this has a pivot position, okay, and this has a pivot position as well. So each column has a pivot position here. So these are linearly independent, right? So V1, V2, V3, the set is linearly independent. Linearly independent. Like I said, it's not enough. You know, you need a third vector. So in order to span R4, you need a third vector. So what will be the span of this looks like then? So the span, let me write it here. So the span of vector is going to be a space which is a subspace of R4. So it will just be in a hyperplane. So you can think of this as a hyperplane. Hyperplane. Sorry. This is because it's just a subset. So this will just be a hyperplane, which is a subset of R4. So in order to span R4 entirely, right? Entirely R4, you need a 4 linearly independent vector. But in this case, we only have 3 linearly independent. So it's not enough. We're just going to span a hyperplane of R4, which is a subset of R4, just like a plane embedded in R3, right? So this will be similar. A hyperplane embedded in R4, but we're not going to be able to the span R4 in this case.